Hey guys, welcome back to class. Glad to have you. We got a pretty exciting topic tonight, I think. A little bit of a departure from what we've done so far. So we're down here in the last weeks, right? We got 2 weeks on this material. Then we got Thanksgiving break, which is coming up this week here, just a couple of days. And then the remaining of the semester is going to be spent towards working on your final project in groups or individual with all those details and stuff. So we're just about there. So this is the last new module with new material. And this one is just about Jupyter. I think originally we had Jupyter and source control. I've dumped the source control. I don't know if it's going to be super helpful for most of you, so I just dumped that, and we're just going to stick with Jupyter, make it a little bit simpler. And so I've just clicked here on the content. I've got it over here in my VS Code, and let's get started on it. If you guys haven't heard of Jupyter before, or Jupyter Notebooks, or even iPy Notebooks, I think was the old name before they rebranded it to Jupyter. Jupyter Notebooks were designed for pretty much exactly what we're doing. They're meant to share your research, your data, your computations with colleagues. So you can just take this one single file, you can share it to someone else, and they can see exactly what you've been doing. It's really good for studies, for sharing data, for collaborating with colleagues, especially across universities or institutions. And it's a pretty good way to do some pre-publication work, with your co-authors and to get things ironed out. There's a way to centralize the notebooks on a server. But the stuff we're doing here in class is just on our local PC, but hopefully you'll see that it's pretty easily served up on a server so that there's a central location. So that's the idea of what it is. And the style and the flow of what Jupyter Notebooks do is they have cell contents, which we'll see in a second. And there's some that's just narrative text describing what's going on, and then there's some cells that actually has executable code in it, like Python. And so this whole semester, every time we've done one of these lessons with the content, I've tried to set them up very similar to a Jupyter notebook, just so you can kind of be in the same thinking. And I also really appreciate the format and the flow of what Jupyter notebooks do. We haven't been using Jupyter notebooks, obviously, but you'll see here pretty soon when we start doing it that it's very similar to this sort of style here that I've been doing with comments for the narratives, and then we have actual working code embedded in it. So it's actually very similar to what I've been doing. So if you like that, then you're going to really love Jupyter. So the first thing we got to do is install Jupyter. Here's a link to their website. You can get some instructions there. But there's a quick command right here. I've already done it, but I'll go ahead and just show you. So just copy this command here. You can do it in honestly any command window, but we're gonna just go to our terminal window. Let me actually bring up this thing. Yeah, so I'm just gonna use this terminal window here. Just paste that in there, do a pip install. Jupyter Lab is actually, there's a lot of stuff involved in it. You can go through and pick out the specific things you want to install, but it relies on a lot of other things. You can see here, it went and tried to download a whole lot of things. So if you just use pip install Jupyter Lab, you get all the things you'll ever possibly need instead of just going to install one thing at a time. So that's my suggestion to you. I've already installed it, so it didn't have to do much, and it just went and double checked that it had the latest stuff, and it's already installed, and I do. So do that on your machine. And once you do that, that installs the two parts. We have the client and the server. And just to sort of explain this paradigm, if you're not sure what a client-server architecture sort of things look like, if you're not computer science majors, you may not. What it means is on the client side, what we're going to see here on our desktops, it could take lots of different forms. All it means on client is that it's the user-facing portion of it. That could be a web page, it could be a mobile app, it could be an installable app, whatever the case, whatever is physically accessible to the user, the client. And then we have another server that we send the requests off to do the actual processing. And so for these Jupyter notebooks, we're going to be using a web page. That's going to be our client, our user-facing portion. And anything we type in there actually doesn't do anything in the web page. It instead sends it off to our server in the background. The server computes and does the work, and then it's going to send back the result to our client web page so we can see what's happening here. And so like I said, this whole configuration is going to be just on our local machines, but the server could easily be a central server that everybody has access to. So that's kind of the idea of what we're going to be doing here. And so since there is a server portion, we have to spin up the Jupyter server on our machines for this to work, because it needs a server to be reading things for us, interpreting for us. And in order to spin up that server, once we've got everything installed, we just need to go type this command in here. So again, just in a terminal window, just type Jupyter notebook. And if it works properly, it should spin up a web page. Let's see what happens. If not, we can go do it manually. There we go. So we can see here, it's opening up a Jupyter server for us. And if you didn't have that happen, you can just go to this web address, localhost 8889. I don't even think you need that tree part. Let me get rid of that and see what happens. It'll default in there, yeah. So you can just go there. And you can see this here. This is our Jupyter server. We'll talk about some of that stuff later. I just don't want to get ahead of what I'm talking about. Yep, so you can just copy this in here. If it didn't open for you, just open up any browser. And if you have the server running, you've typed in Jupyter Notebook, you waited a minute, nothing popped up, and then you go open up a web browser and you copy this address and paste it in, and it still doesn't, nothing happens, then you've probably got a problem with your install, and you'll probably need to figure that out. And you can go to this web page right here to get whatever help and guidance you need. And if you're running a Mac, I don't know how to help you. But again, you'll know it's successful when this web page opens up. Okay. Okay, so let's just go familiarize ourselves with this screen. So the whole idea here of Jupyter client here, this is the client we're seeing. It's just a way for us to go create Jupyter notebooks and to execute them, and then hopefully to share them with other people. So what we see here in the first one is we have this tab for files. We have a tab for the ones that are running, which there's nothing running, and then clusters, which we're not really going to talk about. It's a little bit more advanced than anything we care about in this class. And then down here on the files, this will be the tab we're going to be using most of the time. You can select the filters. You can select location. What happens here is we started it in this project right here. I just have a Hello Doctor project that I've been working on this whole semester. I haven't been renaming anything. And since I went to this terminal window and I did my Jupyter notebook to start the server, it's just assuming this path. This is where it's going to be using and storing everything. It's to that path. In fact, you can see once I started it, it looks for all my Python files, basically any file in that folder, honestly. So I have my Python, my text files, my CSV files, and then I have a couple Jupyter notebooks. These are IPyNB, which is the old name of this product before Jupyter was IPy or IPython notebooks. So that's the extension IPyNB, and there's a couple there. And if we look over here, we can see all this stuff, right? I have an IPyNB right here. I have the apps.py. I have the CSV and the text and stuff like that. Okay. And then just to show you what happens. So if we click on one of the Python files, it doesn't actually execute the Python files. It's just going to open it, let you see what is going on in there. Not a big deal. You just can edit it if you want, save it, download it. Just trying to give you an example here. And every time you do something in the server, opens up a new tab, so you can just close that if you want. Okay. You can also upload files. So this means if somebody has given you a file or is trying to share a file with you, you can have it in your folder, go select something and upload it, or open it and it'll upload it here so that you can execute it. Or you can create a new one from scratch, which is what we're going to do. Go over here to Notebook, we're going to say we click a new Python 3 notebook. There's the only choice under notebook. These other ones are just supporting types of things, folders and files and stuff. So we say we're going to create a new Python 3 notebook. And this is what we'll get. Looks a little bit like Google Docs up here at the top where we've got the Jupyter server. If we click that, we just go right back. We'll leave that. It'll just come right back to where we were. I think this is, yep, this is the one that's running. So we could click on the running tab you can see here. The one we started and opened is running. We can stop it if we want, but it's fine. And it's also green here because it's running, it's active. You can tell right here it's running. So we just go back into it by clicking on it. We can give it a new name, just like in Google Docs, you just click on the name of it. I don't know, give it some useful name. Right, and then we can see how old it is, and then just these are the things that we want to check out here. We have a lot more things to do here than we did when we clicked on the .py file. The ones that really are going to matter though is like the insert, the cell, and maybe the kernel, depending on if we have some issues going on. But the insert and the cell are going to be the main things we do. And then here we have a save and checkpoint. These are some of those same commands here from like insert and cell, just put in icon form. And then we really want to make sure we run things. We can either do run, just like we do in Visuals, VS Code, right? So when we go over here, we have similar things. When we hit start debugging, we get these same commands right here, right? With the red stop, the pause, the whatever. And if we go look over here, we have something similar with the stop and the run. And then we also have those here. If we just click run right here, like run all, for example, that's similar to what this is trying to do here. Okay. And then we have a few different cell types. So these down here are called cells. Let me just make sure I'm not jumping ahead of myself in the lesson here. Yeah. So just make sure you poke around the menus and you sort of understand the environment that we're working in and what we're looking at. And again, this is referred to as a cell. Okay. So in the cell, we have a few different types. You can see it just says in, and then these square parentheses. And then right here is a little blinking cursor. We can just type stuff in here. We have to define what kind of cell this is. So you can go here to cell and cell type. We have a few different choices. We're only going to use these top two for this class. One is code. That's the default. That's what we're looking at here. Let's set it to work as code. Or you have one's called Markdown. And you can see when we have it in Markdown, we get rid of that input notifier. Okay, so just make sure we have the right cell type. Oops, put that back on code. You can see that popped up. So we have nothing going on here. We can hit run, nothing's going to happen. So let me just show you a quick example. Let's actually just use this. We can quickly just type in a standard Python command. I'm going to delete this cell. What is it? Edit, delete cells. Okay, so I'm going to just do that, and then I'm just going to do run all. And when I do it, this code gets packaged up, sent over to the server, which is running on our local machine, and then it puts out the result from whatever that code produces. In this case, it's just the string that says hello world. So that's good, and then we can create a new cell. So we would just say insert a cell above or below. Okay. Let me just show you what a markdown cell looks like. Oops. Change this to markdown. Markdown is just for narratives. And if we say run all, nothing really happens. This is, again, just text or narrative. Okay. And we can insert more after that. So you see the idea here. Let me delete. And then insert cell below. There we go. Okay. Okay, again, these are the commands to do it. Go to the insert menu, insert cell below. So let's do something a little bit more complicated. Let's go here. Because all we did here is just a print line and it's just one line of code. I just wanted to show that you can do multiple lines of code and some semi-complicated things. This is an example taken from one of the past week's lectures where we're trying to figure out those are the pandas in the visualization lesson, where we're trying to figure out what's the max temperature, right? So we have an array of floats. We start out at 0 and we just loop through all of those until we find a higher value, and then we just produce it. So all this code is going to get packaged up, sent to the server. It's going to execute it, and that's going to produce the result and put it here in the cell for us. So we can just say run all. And here we go, right? So that cell of code produced something, and here's the result. Let's insert another one. Okay. There we go. So hopefully you can start to see that we can start building on these things, and it'll start to look a little bit like what we've been doing here all along, with the green commented out code being just these narratives, and then the actual executing code will be these blocks of things, right? Like, yeah, these things right here, for example. Not sure why I did that. Okay, so that's really the basics of it. I think there's maybe, I know talking to other students, they used Jupyter notebooks in maybe a prereq, or in preparing for this class, they may have taken like an online Python thing and they were using Jupyter notebooks. And there was questions about why we didn't just start in Jupyter notebooks and why we even bothered using this VS Code tool. And so I wanted to address that for just a little bit. The main reason is VS Code gives us the ability to do some debugging. So for example, we can set a breakpoint right here, this red line. We can stop the execution of things, and we can inspect variables. So let me show you it's what we've been doing this whole time, but I just want to illustrate what I'm talking about. Oh, I have another error in my code. Sorry, let me fix that. Oh, another error. I think some of the copying over from the content folder to here got some things misaligned. Okay, yeah. So some of this won't run. Grr. Okay, let me get rid of all that. Now let's try it. Okay, let's try save debug. Okay, so when I'm talking about debugging in VS Code, I'm talking about when we hit a red dot, we get this yellow control cursor. And we can step through, we can hit these F10, F11 right here, step over, step into, step out of. We can control where it's going, we can look into all the details that are happening, and more than that, we can hover over the variables, see exactly what's in there. We can step through here and see if our logic is being met right here, like this, right? We can get a better sense of what's going on in our code, right? And we can figure out exactly which lines of code are being hit, which ones aren't being hit, and figure out the result, right? It's easier to figure out what's going on as beginners. If we do that with our Jupyter notebooks, we don't get the ability, we don't get the ability to step into our code. We don't get the ability to look at the variables. We just have to have it written sort of perfectly the first time, and then see that it's working, and if not, just keep working at it. It's basically like we're editing in like a notepad or Microsoft Word at this point. And we can get a decent idea, right? So I purposely just put a mistake in our code right here. This if statement's not indented. So if I try to run this, we will get an error. And it does give us a little bit of indication, right? It's saying our if statement is expected to be indented. So we can get that sort of stuff going back and forth to figure out the syntax errors, and that's fine, but we don't get any idea of what are the semantic or logical errors going on. So meaning we can have really fine code that has no issues and it'll run, but it could be producing the wrong result. And it's really hard to track that sort of stuff down in a Jupyter notebook, right? For example, if I did something like this, if I just had the wrong sign, I did a less than sign, and I tried to run this, this is valid code, it'll run, but it's not going to give us the result we're looking for, right? We think one thing's happening, we get some other result, and we don't really know exactly what is going on or what's wrong. We'd have to really go and inspect this line by line, whereas if we use VS Code, it's very obvious and straightforward if we were to put a breakpoint. And we say, oh, it's not hitting this block of code, why not? And then, it's easy to pinpoint stuff like that going on. So hopefully that makes sense why we started with VS Code first. Okay. Okay, so let's go look at the markdown code. Just looking here to make sure I'm not missing anything. Okay, so there's a couple of guides. I like this one better. I put a couple URLs in here that you can use to refer to markdown code. But the gist of it is it's a very simplified way of adding formatting to text. Traditionally, you'd use something like HTML or CSS. Markdown is a way to do very terse characters on lines that give you similar effects. Here's a couple examples. If you want to create a header, meaning big, bold, huge letters, typically, and this is true in like Word and Google Docs and stuff, you can have progressively smaller headers, right? H1 through H6, for example. And in Markdown format, all you got to do is put the pound sign in front of it. The first one is for header level 1, and then you have 6 for header level 6. And this is what it would produce. Likewise, if you wanted to create a list or a link, this is the sort of thing you do where you'd put these in square brackets and say that this is a link, put those in parentheses, and then it would produce things like this. So this is just giving you an idea of how you could do it in markup if you wanted to put an image or whatever, right? If you wanted to have a code block, something that looks like this. If you wanted to have a table, like an Excel looking thing, you would do these sorts of things. All I'm doing for this is just simple, like, bolding, underline, strike through, header sort of stuff. But if you want to get fancy, I put a couple of links right here that has what the actual characters are you can use. But again, it's just for formatting of text. Nothing's going to actually run. And so I wanted to give you just an example. And it's actually interesting that, so this is now markdown stuff, right? From line 180 down. This is going to be, marked down formatted code. And I'm using header 1 stuff, which is right here, header 1. And it just so happens that the very first character, or the character that identifies it as being a header 1, is this pound sign, this hashtag looking thing. And that's also the same character for commenting code out in Python. So I just want to make sure that we're not confusing markdown looking code with Python code. These are different, and they just happen to have a little bit of overlap here. So let me just get rid of this print world. I'm going to change this cell into a markdown cell, and then I'm just going to paste in what I copied there. And then if I run it, cell run all. This is the sort of thing we get. I put 3 lines of code, and I said that these are H1, meaning the biggest header possible, which is pretty big font and bold. And it produces this sort of thing. And so none of my editing stuff is there. The only thing that we can see that looks editable is this text box. And so we have the smaller text here, maybe describing what we're about to do. And then we have stuff that's actual code. And then this is the output of that code. And then we would sort of keep building on that step by step, right? So imagine you're trying to share your research with somebody. You would probably do some sort of header, talk about the project that you're doing. You would say, here's some of my data. And I'll show you in a little bit how we can include, external data files. And we say, now we're going to read in our data. Here's the first step I did to, transform this data. And you have some code for it, and you can see the result. Then you can keep on working on, your notebook, your Jupyter notebook, to show how you're processing the data for your research. And then you can have others comment and contribute and stuff like that. So that's the whole idea with Jupyter. It's pretty sweet. I'm a pretty big fan of it. So let's continue that, right? So I think I took this from the group assignment. I was getting you started on the group assignment. I think so. From this point in the video on, it's getting our notebook set up for the group project, which is how I want you to turn in the group project, is in a Jupyter notebook. Okay, so let's keep copying this and build up what we got. I'm going to go ahead and delete this cell. Delete cell. Okay, so we're going to create another. Actually, let's just edit this one. If it doesn't look like it's editable, you just got to double click on something and then it comes back to edit mode. So we're just trying to get a little bit of a description. And then if it looks weird like this, all you got to do is just run. I like to hit run all, but you can do whatever. I don't like using this run because every time you do it, it puts new blank lines at the end. But that's your choice. So let's say we're doing the group project. That's what I've called it, the final project. Here's the class, here's your teacher, here's what we're doing, right? So for this project, we're going to analyze the Ohio obituary data between 1985 and 2010. And so we're just going to work up and show you a couple of examples. In the actual project, there's a lot of stuff it wants you to do. And I'm just going to look at one of them, right? So here's all the things that we're looking to have answered. Like 9 or 10 things. Once you do 1 or 2 of them, the rest will be fairly easy, I think. But the one I'm going to look at and try to answer for you is this one. I'm going to take number 3 because that one seemed the easiest to me for this purposes at least. So out of that Ohio data, it lists the state of death. So I don't know if it means Ohioans who died in Utah and maybe came back and were buried, or if it means Utahns who came to Ohio and died in Ohio. I'm a little unclear because it's the Ohio state obituaries and they talk about the state of death. And so there's a bunch of people from Utah there. So I thought we'd just pull those out since we're from Utah. So let's look at that, right? So we're going to build up that stuff. Okay, yeah, so this is what I was going to talk about earlier. We want to, let's get rid of that. We want to bring in our obit file. And Jupyter needs you to do some things to make that happen. Let's get rid of this markdown. Let's, we can save this, and then let's go over to our Jupyter server just by clicking the Jupyter logo. We got to import our data. So let me show you. Go over here to the group project. Here we go. So we have 2 extra files that go with this. We have the obits for, 25 years as a CSV. And we have this extra text file, which isn't necessarily computable in its form, but it has data that you're going to need to know to interpret that. Let me just show you an example here. If I click on this cross-reference data, it's going to have things like in the obit file, anytime it has a 0 for gender, that means it's a male, right? Or if the cause of death is a 2, that means it's cancer. So this is just sort of a lookup table, translations as to what the numbers mean that you're seeing, right? And so here's the one that we care about for what we're trying to do is the state. We're looking for Utah. Specifically, we need to know Utah is encoded as state number 44, okay? So that's what we got in this cross-reference file. Let's go actually download the real obit data though. Where'd that go? Right here. So let's click on that bad boy. I've already done this before, so it's probably gonna show that it's a copy, but I'll walk through it again with you. And it's pretty beefy. It's 3 megs. I mean, not too beefy, but beefy enough that it's gonna take a second to download. I think. Did I click it? I've already got it downloaded elsewhere, so let's go look at that. So we come over here to our server. We've downloaded our data. We just come to the upload. Come to, where is it? Right here. I'm going to rename it though too. Oh, I just downloaded it. Just a second. I'm just going to rename it something smaller so I don't have to remember that whole name. Just obits.csv. We're going to open that. It's going to upload it. Looks like it's going. There we go. So we got this obits.csv. You can see I have a couple of, I did this earlier, I got a couple other ones, but it's the same sort of thing. I got obits, I got the Ohio obits, and I got the big long name, but basically the same thing. So I've uploaded it, and this is something we got to do for Jupyter. It needs to know about this file, and then I don't know if it's required, but I usually shut down and restart my notebooks when I do that. Once this notebooks get started, it knows what's in the session here, and I like to restart it just to make sure it has a chance to go refresh its list and to understand that I just brought in new things. Then I'll click back on that notebook to start it up. Okay, so now it's open, it's ready, and now it's going to know that we have that file available to us. Let's make sure we're not getting ahead of ourselves. Yeah, I was calling it Ohio obits in my example here. So I'll stick with that. I just wanted to show you how we download and upload it into the Jupyter server. Okay. So now we know we have this file. And in order to answer any of these questions, we got to import this file. I'm just going to do, I think I saw an import up here. Right here. I'm just going to go do all the imports I know I need at once, so I don't have to worry about it. So I'm going to create a new code block, which is what I have here. I'm going to paste in my imports. And just to make sure we don't have any issues, I'm just going to run all. And nothing really happened. There's nothing to output. It just did it. I'm just creating it as its own cell. And then let's get rid of one of these just to clean it up. Okay. So we've imported what we need. Now we need to actually go read our obits data. I got a line of code you can use here. Again, this comes just pretty much directly from our module. We did a couple modules. We did the one where we just read and write data using Python's built-in open command. This one's from the later one we did on visualization with pandas, just because I think pandas is a lot easier to work with. A lot less effort on our part. So we just copy these. What we're doing here is we're going to read from our pandas. We're going to go to our pandas library. You're going to go find the read CSV method. We tell it the name of the file we want to import. So change this to whatever name you save yours as. I have a few choices because I downloaded it 3 times. That's one I'm just going to stick with. And we're telling you how we're delimiting it. Obviously it says it's separated by CSV, but it'll let you pick whatever character you want. So it's just saying on every comma, it's going to split up our data. And then we're going to store it into a variable called patients. And then I'm just going to go see how many rows of data it pulled in by just calling the count on patients. And that's kind of what we're asking here. It says the number of obituary records that we analyzed was ... Let's run our code and see. Quite a bit. It's telling us by column. So it's saying all of these columns, or most of these columns, have 64,482 things. This is telling us that our middle initial, we don't really have that many people with middle initials, nor do we have as many for maiden names or spouses. But we have all the data, except for first name. I guess that's interesting, huh? We have all the data for last name, gender, and date of birth, and cause of death. And we're just missing one for the state of death, right? So that's how many data we're getting. We've read it in. We can see successfully read in our data file that we included in our Jupyter server. We just did a little quick count on it to see what's going on. And this is just a test to make sure it's able to read that data. And if you try to do this and it doesn't work, if you can't call patients.count, then you've done something incorrectly. You didn't load the data, or you didn't refer to it properly, or you need to restart your kernel, whatever the case may be. Okay, so let's start building this up now. Let's try to answer the question that was at our fingertips, meaning how many people died, or what was the most common cause of death for people from Utah, I think. Okay. Yep, so this is what I'm saying. We looked at the cross-reference file. We saw that the state code for Utah was 44. Yeah, right here, state code 44. I'm jumping ahead a little bit, but not too much. Oops. So we see that state code's 44. And so we want to find all of our people from Utah. And again, I'm just going to be doing this is taken directly from Panda's last lesson, the last one we did on visualization. Let's insert a new cell at the bottom, paste that in. And so just looking at this code, what we have here is we loaded all of the Pandas data, or sorry, the obits data. We read it through Panda. We stored it in this variable called patients. And so right here, I'm just saying, go look at my patients data set. And the square brackets are saying, go look at this column. And that was the state of death column. It's this one right here. I'm highlighting, oops. This one right here. That's our state of death. So I'm saying, go look at my state of death column. And then just only return the ones that are in a list of values. There's other ways you could write this. You could, say if it's equal to 44. But I just chose the is in. Then we're saying 44. So only just return me the ones that are in 44. And then I'm going to store that in a new variable called just Utah only, meaning all the stuff stored in this variable is only the stuff from Utah, just to simplify our work later down in our notebook. And then we're going to, again, same thing, print it out. So we can see how much our data is reduced, right? We should go from 64,682 down to about 1,271, give or take. Looks like that's the high, right? That's a pretty hefty number though, right? So for an an Ohio obituary file, about 1/60th of it is Utah, which I guess proportionally or statistically would make sense, given there's about 50 states, and I guess they could be from anywhere, not just America. So proportionally, I think that holds up. Okay, so we've got our data. We've read it in. We've filtered it down to get just the Utah people. All right, so we're making progress. But our question is, what's the most common cause of death? So guess what the next thing we're going to do is, now that we have it just for the Utah people, let's go, insert a cell below. Let's go figure out, from just our Utah people, let's go look at only the column of cause of death. And then we're going to store that back here. Okay. And again, just going to show it. Let's run all of that. Okay. And again, this is what we were expecting. 1,271 matches what we got here. So it got 1,271 records of our causes of death. So all that means is out of our 1,271 Utah only people, every single one of them has a cause of death listed. Okay. So we've reduced all these other columns also. So that's what we're doing, right? So we had, last name, first name, gender, whatever. We got rid of all of those and are only looking at the cause of death. So we're only looking at one column now for Utah, and we stored it back here to this Utah only variable. Okay. And again, there's a million ways to do what we're trying to do. I'm just showing you some straightforward and easy ways that come directly from our lessons before, but you could definitely do, a bunch of for loops or whatever you want to do. You don't have to filter by state and then death or whatever. You can do it however you want. Don't think that this is the only way. And that's the best part about programming is it's very creative and it's subjective, and you can go about it, a million different ways, and some are better than others, but it's entirely up to you. So don't think that what I'm showing you here is the one true way to do anything. Okay. The other thing we want to do is we want to do a little bit of sorting, because we have, I can probably print it. Let's insert a cell here. So again, we have 1,200 we have a lot of causes of death. So there's going to be 1,271. This is just showing us a quick breakdown of that. All right, so you got 1,271. So it shows you the first 5, skips a bunch, and shows you the last 5. And again, their cause of death is this code, right, which we have to go look up in the cross-reference table to figure out what these codes mean. So what we need to do, though, is we need to have a way to count those, meaning how many times does the number 1 show up as a cause of death for a patient? How many times does the number 16 show up as a cause of death for all these people? And we need to keep a running count of that. And you can do that, obviously, with some variables and some for loops. Not too big of a deal. It'll take a couple of loops and a couple of arrays, and we could figure it out pretty easily. And I would recommend you do that. But there's also a nice little pandas tool method called value counts. And value counts pretty much does that for us. Value counts does exactly what it just described. I tell it which column I care about, which is the cause of death. It's going to go find all of those distinct values in there and count them. So it's doing all the stuff for us, but that's because we're doing it the lazy way. Some of these other problems you won't be able to do the lazy way, so you'll have to do the actual for loops, and keep track of stuff and iterate over the data, keep track of how many times you see these certain numbers and figure it out from there. But for now, we can do this. Okay, so we're going to go look at our Utah-only data set, go on the column cause of death, which is the only column in there. We've got rid of all the other columns. We've only got this one column in there. And it's going to go count all the values and then sum them up for us. And then I'm just going to show you right here with the index and the values what it produced for us. So let's run it. Now, let's see what we did wrong here. This was working. Got a little too cocky, huh? Okay, I put pause for a second there so I can go figure this error out without having you watch me fumble around. But what happened was I was clicking on this run button and not the run all. So it was starting from a point wherever I was highlighting, and it wasn't keeping in memory all the stuff above it. So that was the issue, but I also deleted one line of code, which was this one. I deleted that block of code. I don't think it had anything to do with it, but you won't see it on my thing anymore. So just in case that was it. Because this narrows it down from all of the columns right here in lines 228 to just this one single column. And so I didn't know if it was going to have an issue here. I deleted it, but it was just fine. And again, it has to do with the way I was running it. I clicked on this run button, which only runs from where it is highlighted, meaning this green section down. So it didn't have all this upper code ran in its memory. So that's a lesson to you again. That's why I usually always click the run all. I didn't at that time. So here is what we get. In fact, I think I want to put that code back in here that I took out because I got too much data here. So let me go put this back in here. Where were we doing that? Right here. So let's insert a cell below that. Paste that back in there. Let's run all of that again. There we go. Nope. So that is the problem. Okay. So this is the problem right here. So if we delete that. I was trying to clean it up for us on our display. There we go. I was trying to get rid of the first and last names and just have the state of death and stuff like that. That's frustrating. Okay. Anyways, the code we got here was these ones. So I said just go do the value counts on my cause of death. All right, so here's my cause of death. Here are the value counts, and then I'm just displaying what we got. You can access those using the index and the values, right? Just think of them like rows and columns. So it's saying for the death code or cause of death code 8, it found it 72 times. This is sorted, by the way, right? It's not showing death codes 1 through 20 in order. It's showing them sorted based off the most common down to the least, That's what the values count method does. Sort of puts it in histogram format, or Pareto, if you want to think about it like that. So it's saying death code 8 is the most common, happened 72 times. And then number 12 and 9 had a tie at 71, whatever those are. And then, just rounding out the top 5, we got a number 16 and a number 6. Right? So quite a snazzy little method that'll go do that stuff for us. At least I think so. Okay, I went through the cross-reference and looked at them for us already. And the code of 8 is influenza and pneumonia. Number 12, the chronic liver disease and the kidney disease. And then surprisingly, number 16 is violence and murder. I was pretty surprised to see that as a top 5 one. I don't know if that speaks to Ohio or or what. Anyways, so we've basically answered this question. We would want to put something in here, like a markdown text saying, we can just do it really quick. Change our cell type. Oops. Cell type markdown. And we could just say something like this. Probably don't want the pound sign because that's going to make them enormous. Oops. Something like this. Solution to number 3. The most common causes of death are, make that a little bit smaller. Oops. There we go. And then we can just say, I don't know, however you want to do it, doesn't really matter. There we go. I forget what this one, I think it was 66 maybe. There we go. Then we can just execute all that. There we go. So you could do something like this so that it's clear that you've answered the problem. Here's the solution. If you want it on new lines, it looks like it's wrapping it all into one on Markdown. You just got to double space it. Oh, there we go. So now they're on their own lines. Or you can go put them in a list. There's special codes for how to put them in like a bulleted list or numbered list or whatever. But that's sort of the idea. And then let's take it one step further, because a couple of the questions have you do some graphing, I think, for the final project. So I just wanted to show you how to get that going in case it seemed daunting to you. I already imported the matplotlib library, I think. Yeah, right here. So the very first line, I imported our graphing library, matplotlib. Let me insert a new cell. And now, again, this is just taken directly from the last module lecture we had on visualization and pandas using the matplotlib. But we can just build our plots. This one is a bar graph. You may choose a pie chart or something else. I thought a bar might be the most appropriate here. Again, pie is going to take a little bit of extra work on your part, but you can do it. We're just going to give it the title, meaning these are the most common Utah deaths in Ohio. I think that's what the data is telling us. And then I'm passing in the data, literally the data we just calculated. So I don't have to put in any actual values. It just knows it on its own. So let's do that, right? So we literally just did these things, right? We did these calculations and we got this result, and that's all I'm going to pass into it is the index and the values. And it'll figure out how to graph it for us. It's very, very simple. But just to show you, run all, just to show you that it works, and here we go. These are our most common Utah deaths in Ohio, and sitting here at 72 or 71 or whatever the number was, 72, is cause number 8. It takes extra work to convert those numbers into, the actual causes of death to say something like influenza, pneumonia. You can go through those steps if you want. I didn't do it. I'm just showing the numbers 8, and this is sort of, I guess corresponding and backing up the data we're talking about. But that's how you would put a graph in here, and it's pretty simple. And then it's, again, just sort of like a histogram with the most common here on the top left, and then all the way down to the right to the least. And then you just have to look up in the cross-reference what each of these are. And you can be more, I don't know, prettier than what I got going on here, but this is getting the job done. Okay, so finally, let's actually be done with our work. So we've got this big snazzy Jupyter notebook. It's got a whole bunch of text. We've got some data we imported. We got some narratives. We got some code being run. We got some pretty output happening with our data and with our graphs. And we want to share it with somebody, right? We're like, oh, we got this colleague. We want to have their input on what we're doing. How do we share it with them? There's a few different ways. If you have a big common server in Jupyter Notebook, you would just share it with them. Since we're not doing it that way, and we can't guarantee that it will be that way, we can do the simpler way, which is we just save it. And we can download as a notebook right here. You have other choices, obviously. Oops. You can see them all here. I prefer, or what we've been doing here, I should say, is the Python notebooks. I'm actually curious what happens when we do that one, though. But we just say save it as a Jupyter notebook. And here it is right here. It downloaded it. Or yeah, downloaded it for you. You can go do whatever you want with it. Now you can go copy and paste it. You go email it to somebody. You just need to make sure that when you do that, you also send them the data, because that's going to be in a separate file, right? The data is like 3 meg. This little Jupyter notebook's tiny. It's only 15K. So you got to send the data along with your Jupyter notebook. And just to show you what it looks like inside, this is what it looks like. It just creates these are called JSON objects, JavaScript object notation. It's nothing you need to know because it's doing it for you. I'm just showing you behind the scenes. You can go look at it, and then each of the cells describes what it is and what sort of content's in there. Yep. And then again, the output and stuff like that. So they can go up and load this all themselves, and they can go monkey around with it and figure it out. Pretty straightforward, I think. And then likewise, if someone gives you a Jupyter notebook and wants you to run it, you would go here to the server. You would say upload. Let's do the Chad's demo. Let's actually give it a different name because there's already one there. So I just did that. So this is my lame demo. Click it, open it. Here we go, we got it. Let's upload it. Which one? This one. Chad's lame demo, right there. Let's click it, and boom, now we've got someone else's work here. And it happens to work because I have the Ohio obits.csv already in my Jupyter server. Ohio obits right here. But if they had data that went with it and they didn't send it to me, we wouldn't be able to run that. So again, just go through those steps of uploading the data separately. And that's it, you guys. Pretty simple, I think. Pretty straightforward. Hopefully you like this Jupyter stuff. I sure do. So make sure you do your final project in a Jupyter notebook. And then for the assignment for this module, it's just taking any of the assignments we've done in the past, like literally any one of them, and then just convert it into a Jupyter notebook. Just make sure that your Jupyter notebook has both markdown cells as narratives and then actual Python cells as code. And don't put all of your code in one massive cell. That's probably tempting to do. Let me just show you what I mean by that. So don't do something like this. Right, so you could pretty easily just do that and just be done with it. And that's not the point of what we're trying to do here. You're trying to do these in little incremental steps, building them up one by one, not have one massive gargantuan thing. I don't even know if that would run. Let's see what happens. No, it didn't run. I had some syntax problems in there. But the whole point is not to have one big massive box and be done with it. It's to break it up logically so that you can share this data with people and they can follow through the steps and the work that you're doing. And that's the whole point of Jupyter Notebooks here. Okay? Okay, you guys. We're almost done with the semester, so hang on, work through it, and you're doing great.